Right, we're starting with lesson 9M2 and it's on advanced triangles. So firstly, we're going to look at the following information. We're busy still with geometry. The sum of the interior angles of a triangle is 180 degrees. So in other words, that means when you add angle A, angle B, and angle C, you get 180 degrees. So the information I'm highlighting is important bits of information which you will be using right through this current lesson as well as the ones you do in future. So it's important facts that you need to know. Triangles can be classified as the following: acute angled, obtuse angled, right angled, scalene, isosceles. Especially the isosceles is important because we're going to work with this type of triangle numerous times within the next couple of lessons, where it's important that you know that two sides are the same in length, and also the angles opposite these sides are also the same in length. So this angle is the same size as that angle because the side across that angle or the side opposite that angle. In other words, this angle's opposite side is this side over here. So in other words, the angle and the side opposite that angle, they have a relationship because due to the fact that this side is equal to that side, the reason being for these two angles being also the same side rests upon the fact that the side and vice versa, the angle opposite the side is equal to the side that's equal in length. Therefore, that side's angle is also the same size. So, in other words, this side is equal to that side. Therefore, the angle opposite this side will be equal to the angle opposite this side. And then also the equilateral triangle where all the sides are the same length and the angles are 60 degrees each. And when we add them together, we obviously get 180 degrees. Right, then equal sides opposite equal angles. Note the length of a side of a triangle depends on the size of the angle opposite that side. So in the diagram, AB equals EF equals QP equals NH. And BC equals FM equals PT equals HK. Now, EM is greater than AC for the simple reason angle F is bigger than angle B because angle F equals 105 degrees and angle B equals 75 degrees. Therefore, side EM is longer than side length AC. So the reason for making this statement is because angle F is greater than angle B. So take note on how to give your reasons mathematically and what will be acceptable. So this is the acceptable way of writing it. Then QT, to make it a different color, is bigger than EM because angle P is bigger than angle F. Angle P is 125 degrees and angle F equals 105 degrees. Therefore, QT is longer in length than EM. And then NK equals EM. So they are the same length because both of them are opposite an angle which is exactly the same in length. So angle F is 105 degrees and angle H is also 105 degrees. Therefore, side length EM is the same length as NK. In any triangle, we find the longest side opposite the largest angle and the shortest side opposite the smallest angle. So that will be easy to remember. So we're going to NB that. So make a summary for yourself. When we, for example, compare this one and this triangle over here, then we can also say that NK will be greater than AC because angle H is bigger than angle B. And if we compare, for example, this triangle and this one over here, then we can say that QT is greater than AC in length because angle P is greater than angle B. Because angle P is 125 degrees and angle B is only 75 degrees. In triangle PQS, the longest side QS is opposite angle P, which is 125 degrees, and the shortest side QP is opposite angle S, which is the smallest angle. So the longest side is opposite the biggest angle, and the shortest side is opposite the smallest angle. In triangle TKR, TR is bigger than or longer in length than KR. Because angle T, which is 30 degrees, is smaller than angle K, which is 120 degrees. And the side that's opposite angle K is TR, therefore TR is bigger than KR, and KR will therefore be the shortest side because it is opposite the smallest angle. In other words, angle T. And then you also need to take note that KR is equal to KT because the angle opposite KR is 30 degrees and the angle opposite TK is 30 degrees. So both of them have the same size angle, therefore both will be the same size in length. So please take note of the correct way of giving a reason. Then example 1, determine the value of x. So you get a triangle KLM and we give you the algebraic size, we give you algebraic measurements for the angles, not 100% precise measurements for the angles or sizes, but you will see we're first going to determine now the value for x because we don't know the actual size of 3x when we refer to an angle. So firstly, you're going to now use this rule where all the interior angles of a triangle add up to 180 degrees. We're going to use it now because we're going to say we're going to add all three angles. 3x plus 1/3 x plus 60 degrees equals 180, and then very importantly your reason will be the angles of a triangle equals 180 degrees. So very important that you give the correct reason. So the reason is extremely important. Right, so then you have all your x's on the left hand side of the equal sign, so we add all the x's, then you get 10 over 3x equals 180 minus 60. Then you divide, in other words you're going to times the reciprocal of 10/3 and that will be 3 over 10, so then you get x equals 36 degrees. Right, so in other words it's the same as you would solve x in any other equation. You add the x's together, you subtract the 60 degree on the left hand side, And you have to do the same on the right hand side of the equal sign. Therefore, you see this minus 60 on this side, because remember, we want in the end x on the left hand side of the equal sign, and on the right hand side of that equal sign we want the degrees for x. So therefore you always try to get your x's on the left hand side and the other values or degrees on the right hand side. And then question 1.2, hence determine the size of angle L and angle M in degrees. So angle L, 3x. So you're going to take 36 times 3. So in other words, this is how you would write it. Angle L equals 3x. Substitute x for 36 and you get 108 degrees. Then you do angle M, which was 1/3 x, 1/3 times x. So you substitute the x for 36 because that's the value for x, and you get 12 degrees. So angle M equals 12 degrees. And then our next question, prove that Km is greater than KL. Now the only reason or the only way you can do that is to focus on the angles opposite that side. So we will have to prove that angle L is bigger than angle M, because the angle opposite KL is angle M. So now you just compare the two. So angle L, which we proved was 108 degrees. You see, you have to still give a reason for why you say angle L equals 108 degrees. You just mentioned, I proved it earlier on. That's why we used the word proven in brackets. Then you say angle M equals 12 degrees. The same thing that has already been proven. And then you can say that angle L is greater than angle M in size, because 108 degrees is bigger than 12 degrees. Therefore, the side opposite that angle, Km, will be greater than the side opposite angle M, which is KL. And then you put in brackets, longest side opposite largest angle. And that's your proof. So the main place where most people now make mistakes in grade 9 is when they want to give their own types of reasons for geometrical facts. So please take note on the correct way of answering a question such as this one. It might have been easy for you to get to an answer in order to determine x, but the reasons for making certain assumptions is very important. So, for example, if you didn't write this reason, you would have lost many marks for a question such as this. So please remember to, every time when you write something down or come to a certain conclusion, then you have to say, how did you get to this way of reasoning, or how did you know that, for example, you have to put the three angles equal to 180 degrees. Then you have to write that angles of a triangle equals 180 degrees. Right, you're going to do exercise 1 now, and you're going to use 5 minutes in which to do it. So you get 5 minutes in which to do exercise 1, and thereafter we're going to mark it. So press pause now on your computer screen, and then you work it out, and after 5 minutes you press play again. Right, we're going to mark exercise 1. So you get this triangle MKN, and you need to determine the value of x. So obviously they will ask a question such as this because we don't know what each angle measures, because we're sitting with algebraic values such as x's, which are at this stage unknown. So we don't know what is the value for x. So firstly, we're just going to add all three angles and equal it to 180 degrees. So this equation is very important, but even more important, the reason for it, angles of a triangle, and you have to name the triangle, because imagine you have 4 triangles that are overlapping, then how would we know which one you're referring to? So you have to mention, even though there's only one triangle, you have to mention the name of that triangle. So angles of triangle KMN equals 180 degrees. So this is very important. All your x's on the left hand side of the equal sign. So this, we're going to say plus 10 degrees on the left hand side, plus 10 on the right hand side, minus 40 on the left hand side, minus 40 on the right hand side, and then you get to minus 30 all in all together. So 180 minus 30 gives you 150. You add all the x's together, you get 5x. You divide by the 5 on the left hand side, you divide by 5 on the right hand side of the equal sign, and you get x equals 30. So now we can substitute the x with a 30, and then we can actually get actual values for the angles. Now hence determine the sizes of angle K, M, and N in degrees. So angle K, 2x minus 10 degrees, substitute the x with the 30 degrees because x's value is 30 degrees, and then you get K, angle K equals 50. Then you do angle M equals 2x, substitute the x with the 30 degrees, and you get angle M equals 60 degrees. And then angle N, let's first do this one over here. Angle N, x plus 40 degrees, replace the x with 30 degrees, so 30 plus 40 degrees give you 70 degrees. If you choose to do the other method, where you just say angle N equals 180 degrees, because that's the sum of the 3 inner angles of a triangle, and you subtract angle K and angle M, then you will also get to 70 degrees. But now you have to remember, the main thing is now you have to give this additional reason, because how did you know to subtract the other two angles? It wasn't just a straightforward sum like this where you say angle M equals 2x and then you just substitute the x with a 30. So you have to give this reason. This is additional stuff that you have to write down. Then 1.3, which one of KM, MN, or KN, in other words the sides of this triangle, is the shortest side of triangle KMN? So now we're going to look at the angles opposite these side lengths. So we're firstly going to look at the shortest one. So you look at the angle which is the smallest angle, and in this case it will be angle K. So let's look at the side that's opposite angle K, and it will be MN. So MN is the shortest side, but you have to mention what the other sides measure in length. So KM equals, or is opposite angle N, and that angle is 70 degrees. KN is opposite angle M, which is 60 degrees, and MN is opposite angle K, which is 50 degrees. So therefore, MN is the shortest side, and your reason, shortest side opposite the smallest angle. So for safety's sake, write down all three the different angles with the names of the sides that are opposite them, so that the examiner or moderator can see how you went about in thinking and getting to your answer mathematically. So if you see this question counts 2-3 marks, then you know you have to mention also the other angles with their sizes and the angles or the sides opposite those specific angles. And then you get to your conclusion that MN is the shortest side. Right, now we're going to look at example 2. Why is angle C equal to 50 degrees? Now, what's very important is that you never ever, and I'm going to emphasize it, you must never ever use the example or the reason that you use in school that it's a isosceles. Therefore, angle C will be equal to 50 degrees. That is not a reason. It's not mathematically allowed at ADMAPS to use that as a reason. So this is how you should do, or how you should go about in answering a question such as 2.1. Angle 2 equals angle A. So angle C equals angle A equals 50 degrees. So in other words, angle A, angle C, they are both the same in size, and the size is 50 degrees. Therefore, this is your very important reason. AB equals BC. So the reason for angle C being 50 degrees is because side length AB is equal to side length CB. So once again, we're going to NB this, because that is your reason. You cannot use the reason it's isosceles. So take note. 2.2, determine the value of x. So now you're going to say x plus 50 plus this 50. And as you get to your various answers, always remember to add them to the sketch provided. So 50 degrees plus 50 degrees plus x equals 180. And your reason, angles of triangle equals 180 degrees. Therefore, x equals 80 degrees. So in other words, you get x plus 100. You subtract the 100 on the left-hand side. You have to do the same on the right-hand side, and you get the value for x as being 80 degrees. And then you can also test it. 50 plus 80 should give you 180, and it does. Therefore, it's correct. 2.3, you have to prove that AB is smaller than AC. So once again, we're going to look at the angles. So add every little bit of information you get. So this is angle AB, and this one is angle AC. So AB should be the shortest side. So AB is opposite the 50-degree angle, and AC is opposite the 100-degree angle. So therefore, you're going to use the angles as your way of thinking and as the reason for it. So therefore, you will say angle C equals 50 degrees, and your reason is because you proved it. Initially, they didn't give you the size there, so you have to write down in brackets, I proved it. Then you say angle B equals 80 degrees. You can write in brackets, initially it was x and we solved x, or you can just write down proved it or proven, just like you see over here. And then you can say angle C is smaller than angle B because 50 degrees is smaller than 80 degrees. Therefore, the side that's opposite that angle will be smaller. So AB will therefore be smaller than AC because the shortest side is opposite the smaller angle. Example 3. You will see all of these examples are very repetitive of the rule we're currently using. Determine the value of x. So once again, you get your triangle, and I mentioned that QR is equal to RP. So therefore, the angle opposite this side, in other words, this one over here, and the angle opposite that side over here will be the same in size when we work with the actual degrees. Currently, it doesn't seem like it's similar because you're working with algebraic expressions over here, but we're going, or bits of information that's in algebraic form with containing unknowns like x, but we will get there. So firstly, you're going to say, in order to determine the value of x, we know that angle Q is equal to angle P because of QR being equal to RP. So this is how you would write it out. 3x minus 20, that angle Q there, equals x plus 40 degrees, this angle there. Your reason, QR is equal to RP. X is on the left. Divide by 2 and you get x equals 30. So now you can substitute the x with a 30 and you will see. Here you will have 70 degrees. Over here you will have 70 degrees. Take note, nowhere you see in brackets isosceles as a reason, so you cannot use it. 3.2, you have to prove that QP, in other words, the side over here, is smaller than RQ. So once again, you're going to work with the angles opposite these sides. So once again now, we're going to have to figure out what is the size of this angle, because this angle is opposite this side over here. So how to go about it? You have 70 plus 70, which gives you 140. And we know that the inner angles of a triangle adds up to 180. So in other words, this one can only be 40 degrees. So we're comparing this angle and that angle over there. So clearly RQ is opposite the larger angle, which is 70 degrees, and QP is opposite the smallest angle. So this side will be smaller or shorter, in other words, in length than QR, for example. So, but how do we write it down? So you write down angle P equals x plus 40. You substitute x with 30 because that's the value of x, and you get to angle P equals 70 degrees. Then you go to angle Q, you say angle Q equals 70 degrees, reason being RQ equals RP. Then you say angle R, because we don't know yet the size. Angle R plus 2 times the 70 degrees must be equal to, or must add up to 180 degrees, because the angles of a triangle equals 180. Then you get angle R equals 180 minus the 140, you get angle R equals 40 degrees. And now you say that the angle opposite angle R, the side opposite angle R, QP, will be smaller than RQ because of angle P being larger than angle R. So the shortest side opposite the smallest angle. Right, now you're going to do exercise 2, and you're going to get 10 minutes to do number 1 and number 2. So press pause on your computer screen, give yourself 10 minutes in which to work it out, and then you press play again. So press pause now. Right, exercise 2. Determine the value of x with reasons. So you're working with a triangle. They're telling you that AB equals BC in length. So the angle opposite AB, which is angle C, will be equal in size to the angle opposite BC, which is A. So we have the size of angle A, so therefore we actually have the size of angle C as well. And we know that angle B currently equals 3x. So you guys can already see in which way I'm going to go about in solving this question. So 1.1, the correct way of writing it down will be angle C equals angle A equals x plus 27.5 degrees, and the most important part, BC equals BA, or you can say BA equals BC. Then we add all three together and we equal that to 180 degrees, with the most important part, the reason the angles of a triangle equals 180 degrees. You get your x's on the left hand side. In other words, you're going to subtract the 27.5 twice from 180, and then you get to 125 degrees. Then you divide by the 5 on the left hand side and you divide by 5 on the right hand side of the equal sign. You get x equals 25 degrees. So now you can substitute the x with 25 degrees. So as mentioned, always write down all the new bits of information as you go about in solving a specific geometrical problem. So 1.2, hence determine the sizes of angle A and C in degrees. So angle A equals angle C equals x plus 27.5 degrees. You replace or substitute the x with 25 degrees. Then you get 52.5 degrees. So angle A equals 52.5 degrees, angle C equals 52.5 degrees. Which side is the longest side of the triangle? And then you need to give a reason for your answer. So now you say angle B equals 3x equals, in other words, 3 times the value for x, which is 25, which gives you 75 degrees. Angle A and angle C, they are the same in size, and both of them are 52.5 degrees. And angle B is 75 degrees. Therefore, AC is the longest side because it's opposite the largest angle. So the longest side opposite the largest angle. Very important. Like, you won't believe me, but the reasons are of more value at this stage than anything else, because even though your calculations are correct, you won't get all the marks if you don't give the reasons for example, why you put this equal to 180 degrees. You add the angles and you equal it to 180 degrees. It doesn't mean a thing if you don't give the reason. The same here. The longest side opposite the largest angle. You have to write it down. And then number 2, determine P1, angle P1, in terms of x. Sometimes it happens that we have a problem, like now, when the color doesn't want to stay on the paper. Right, P1, angle P1 in terms of x, and you need to give reasons. So once again, they mention that QP equals QR in length. Therefore, angle P1 will be the same size as angle R1 because they're opposite these sides that are equal in length. But we just want the size for angle P1. So you say angle Q1 equals 1/3 times x. Because we have the following. And remember, now you have to use the information of last week or your previous lesson. So you have your parallel lines over here. So you guys can clearly see the Z over here. Alternate angles. You have to mention the lines also which are parallel. AB is parallel to CD. So therefore, angle Q1 will be 1/3 x. So now we have angle Q1, and you mentioned that angle R1 angles equal angle P1. The reason QP is equal to QR. And now we're going to add all three angles together, equal it to 180, because the angles of a triangle should always add up to 180. Then you get 2 times angle P1. Why? Because angle R1 is the exact same size as angle P. So to make it easier, just write 2 times angle P. Plus 1/3 x for angle Q1 equals 180. Remember, you want to determine angle P, so angle P will be the one that's standing alone on the left-hand side of the equal sign. So therefore, we're going to subtract minus 1/3 x. So we're going to subtract 1/3 x, therefore you see the 180 degrees, which you saw originally. You subtract 1/3 x on the left-hand side and on the right-hand side. Now you see it on this side. Now you're going to divide by 2 on the left-hand side, so then it falls away. Then you only have angle P1, and you have to do the same on the right-hand side. So therefore, you see it now there. And now you're just going to write this fraction in 2 separate bits. 180 divided by 2 minus 1/3 x divided by 2. Then you just simplify it. 180 divided by 2 gives you 90. Minus, you simplify this fraction, you get x over 6. So angle P1 equals 90 degrees minus x over 6. So that's your final answer. Right now we're busy with still the triangle, prove 2 sides of a triangle equal. So we're busy with the theorem. The angles opposite equal sides of a triangle are equal. So angle P will be equal to angle R if, and this is your reason, QR equals QP. So take note, they give you the sides, they're asking the angles. So in other words, the information that they give you will form the reason. The part that they ask is what you write first. So they give you the sides, that will be your reason, and they ask you the angles. So that is the one theorem, the one that we've been doing now for the past couple of minutes now. So now we're going to do the converse theorem. Now they're going to give you the angles and they're going to ask you the sides. So the sides opposite equal angles of a triangle are equal. So QR equals QP when angle P is equal to angle R. So now you're going to get the angles and you're going to prove the sides. So the angles will now form part of your reason, where previously when you did the normal theorem, they gave you the sides and you used the sides as the reason and you worked out the angles. Now they give you the angles and you have to work out the sides. So it's a vice versa kind of thing. So now example 4. We're going to apply it now. So you can now see, you get the angles. It's different now. They don't tell you that RT equals RM, for example. Now they tell you angle R equals 70, angle T equals 55. So now they mention in triangle RTM, angle T equals 55 degrees and angle R 70 degrees. So you now need to prove that RT equals RM. So you see it's now the opposite. So you say angle R plus angle T plus angle M, and we don't have the measurement for that angle size there yet, but we equal it to 180 degrees. So it's almost the same as saying they could have said the following. They could have said, okay, this is X then. but they didn't. So it's the same thing. They didn't give you the degrees there. You're going to work it out now. So 70 plus 55 plus angle M equals 180 degrees. You add these two together, 70 plus 55 gives you 125, and you subtract it from 180 to get the angle M, and angle M equals 55 degrees. So now let's just write that down. Always just write it down, all the bits of information. And remember, the question proved that RT equals RM, and now we can say that angle T equals angle M, and both of them are 55 degrees. Therefore, the side opposite this angle, which is this one, is equal to the side opposite the other twin angle, which is this one. So therefore, RT equals RM, because angle T equals angle M. So remember, the reason is extremely important. The sides are equal because the angles opposite the sides are equal. Very, very important. Now example 5. Express angle M in terms of x so that Kn and Km are equal in length. So then you just mentioned Kn and Km can only be equal in length if the angles opposite Kn and Km are equal. So in other words, angle M and angle N should both be then equal to 2x, because Kn then equals Km. Then 5.2, suppose Kn and Km are equal. So Kn equals Km. Determine the size of angle K. Right, so we know that this angle then over here will also be 2x because it's opposite side length Kn, and that angle is opposite side length Km, and Km is equal to Kn, therefore these two angles are the same size. But now we just need to determine this one, so we will say angle K plus 2x plus 2x equals 180 degrees. That's what you see over here. The reason angles of a triangle KLM equals 180 degrees gives you 2x plus 2x plus angle K, with your reason that Kn equals Km, therefore we can say both of them are 2x. You see, this is the reason you have to give for saying that. And then you just substitute the x's with 15 degrees. Then you get 2 times 15 plus 2 times 15, which gives you 60. So 60 degrees plus angle K equals 180. And then you just subtract the 60 on the left-hand side, and you subtract it on the right-hand side, and then you get 120 degrees. So therefore, angle K will equal 120 degrees. And then you can always just test it. So let's just write it down. 30 You always need to just taste it for yourself. Right, now you're going to do exercise number 3, and you're going to give yourself 15 minutes in which to complete it. So you're going to press pause now. You're going to work it out in the next 15 minutes, and then you're going to press play again. So you're doing the following now. Exercise 3 is number 1, 2, and that's it. Number 1 and 2, you get 15 minutes to do it. So press pause quickly. Right, let's quickly mark it. Exercise 3, prove that MN equals MK. So in other words, we need angle N1 and angle K1 to be the same in size eventually. But obviously we will first have to work out other angles before we can get to that. So you will start off like this. Always make use of parallel lines because you might have corresponding or alternate or co-interior angles that can first help you to get to some of the other missing angles that will help get you to angle 1, N1 and angle K1. So first of all, angle M1, this one over there, equals 30 degrees, vertically opposite angles. See, this is your first lesson, the work we did in our first lesson. So vertically opposite angles, you fill it in as seen here, write it down. Then you go to angle K1, this one over here. So you will say, for example, angle K1 equals 180 degrees minus 105 degrees. Now, how did we get to that? Now, you see you have your U here that's on the side for your co-interior angles. So remember, we always look for the U for the co-interior angles when we work with the parallel lines. So you have your 105 degrees there. And then this angle, remember, currently we don't have this angle over here. So you say 180 degrees minus 105 degrees will give me that angle K1. And the reason why you can use co-interior angles being supplementary is because AB is parallel to NL. So look at your reason. Co-interior angles AB equals NL. So line AB is parallel to line NL. So now you have your 75 degrees there because 105 plus 75 degrees give me 180 degrees, and co-interior angles that are supplementary will add up to 180 degrees. So therefore K1 equals 75 degrees. Now we have one of the two angles that we need. So we have the angle opposite this side. Now we just need N1. Angle N1 equals 180 degrees minus the 30 minus the 75 because angles of a triangle, and please mention which triangle, MNK equals 180 degrees. So now we use the interior angles of a triangle because we have two of the three angles already. So therefore 180 degrees minus the 30 degrees minus the 75 degrees gives me angle N1, which is 75 degrees. So now you can say that angle K1, which is 75 degrees, and angle N1 equals one another in size, and the size will be 75 degrees. Therefore, MN equals MK. And please always give your reason. Angle N equals angle K. So please remember to not leave this part out. It's very, very important. It seems like, or it might feel that you are repeating yourself, but remember, you have to give a reason for everything you write down. Then number 2, give reasons for your statements. Determine angle F1. Right, so once again, we have parallel lines. So the size of angle F1, you will say angle F1 equals angle E1 because DF is equal to DE. So remember the two lines there. So DE, the side over here, is equal to DF, and the angles opposite these two sides will be F1 and E1. So therefore we say angle F1 equals angle E1, and our reason. But we don't have the size yet. We're getting closer to it. So now you just say angle F1 plus angle E1 plus angle D, which is 40 degrees, equals 180 degrees. The angles of a triangle DFE equals 180 degrees. Right, we know that angle E1 is the same size as angle F1, so therefore we replace, instead of writing F1 plus E1, we just say 2 times F1 because they're the same size, plus 40 degrees, because that's the size of angle D, equals 180. We subtract the 40 on the left-hand side, and we subtract the 40 on the right-hand side because we just want F1, angle F1 standing alone on the left-hand side. So then you get 180 minus the 40 gives you 140. You divide by 2 because you just want to know what is angle F1, not two of them, just one of them, because that's what the question states. And then you get angle F1 equals 70 degrees. So you started off by using this two opposing sides that are the same length, therefore the angles being the same size. Then you added the three angles, you added them and equal it to 180, and you determined the size of the unknown angles. And because they're the same size, we just divided them by 2 because together we knew that they were equal to 140. Therefore, one of them will be 70, and then obviously the other one will also be 70 because they are the same in size. Then 2.2, determine angle 2T2. Okay, so I just quickly want to just highlight the bits of information. Just determined. Okay, so now we have to determine this one. So we're going to use our parallel lines. And you will see angle T2 equals angle F1. Angle F1 is 70, so just take a look. So you guys can see the Z over here for the alternate angles. So 70, so angle F1 equals angle T2, alternate angles of a triangle, and you mention the names of the lines which are parallel. Therefore, angle T2 will be 70 degrees. There you have your 70. Then that's your 2.2. Then question 2.3, prove that KP equals TP. This side should be equal to this one over here. In order to do that, we will have to prove that K1 equals angle K1 equals angle 2T. So we start off with angle P1 because we have this angle already. So it will be, we will use the straight line. So you will say angle P1 equals 180 degrees minus 140 degrees because together they form a straight line. So you will get angle P1 as 40 degrees. Straight line, and mention the name of that straight line. So now you have this angle. So now you say angle T2. So write down your 40 degrees there. You have your 70 degrees here already. So now we're just going to add the three inner angles and equal it to 180. As seen over here, because the angles of a triangle and mention the name of that triangle adds up to 180 degrees. Therefore, angle K1 will be 70 degrees. Alright, so now we determined the 70. So now we can say that TP equals KP. So KP equals TP because angle T2 equals angle K1. Right, now we're quickly going to do a little bit of revision on exterior angles of a triangle. So the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So we give you a triangle ABC. You need to prove that angle PBA, in other words, this angle over here, containing angle X and angle Y, is equal to the sum of angle A plus angle C. So when I add angle A and angle C, I need to get this angle. So the sum of angle A and angle C will give me the size of angle ABB, in other words, X plus Y. So to construction, draw BT parallel to AC. So these two lines, they're parallel. So prove that angle A equals Y. Right? Alternate angles, TB equals AC. So you can see we're using the alternate angles, the Z there. And you can make it easier for yourself by just using colors. Alright, and then angle C. So use a different color. Angle C equals equals X. Corresponding angles, once again, AC is parallel to TB. And now it's easy to say X plus Y equals angle A plus angle C. Therefore, now we replace angle X or X plus Y with angle ABP because X plus Y is equal to angle ABP. And that's what they ask us to do. You need to prove that angle PBA equals angle A plus angle C. And angle PBA is X plus Y. And we just proved that X plus Y equals angle A plus angle C. So there you go. Example 6. Determine the value of X. Right, so firstly, they give you 2 out of the 3 angles. And they want you to determine X, the value for X. So firstly, we'll say X equals, and remember this is the outer angle, the exterior angle. So the exterior angle is equal to the sum of the two opposite interior angles. So we're going to say X equals 37 degrees plus 49 degrees. The reason being exterior angle of triangle ABC. And that gives us 86 degrees. So X equals 86 degrees. Then example 7, determine the value of X. So once again, you have two opposite interior angles that you're going to add in order to get the exterior angle. So 2x plus 30 equals x plus 42 plus 18. So we're adding these two, equaling it to 2x plus 30, exterior angles of triangle ABC. Subtract 30 degrees on the left-hand side of the equal sign and 30 degrees on the right-hand side of the equal sign. You get x equals 30 when you add all of it together. And before we get to that, you remember to divide by 2. So you will subtract 30 from 60. Then you will get, for example, 30, and then you just divide. Oh, sorry, I didn't see the x. So Firstly, you subtract the 30 on the left-hand side and you subtract the 30 on the right-hand side. Then you get to 30 and 2x minus that x, because you subtract x on the left-hand side of the equal sign as well as on the right-hand side. Then you have only one x left, and then you get x equals 30. So remember, this x must come to this side, and in order to get that, you have to subtract this x on the right hand side as well as on the left hand side. And this 30 you subtract on the left hand side as well as on the right hand side, because you want only the unknown x on the left, because the question states determine the value for x. So you want x equals and then its value. Then example 8, determine the value of x. So BC equals AC. So in other words, angle A will be the same size as angle B, because AC equals BC. So we will add these two angles and equal it to 3x minus 25. And the reason will be an exterior angle equals the sum of the two opposite interior angles. And that's what they show you here. Angle A, this one over here, we're first going to say is equal to angle B because of AC being equal to BC. Right? And then we're going to add these two together and equal it to 3x minus 25 degrees. And that's what you see over here. Exterior angle of a triangle ABC. And then you will get the value of x as 22,5 degrees. Or you can go this route. And you basically then just do this step and this one in one. So you will say, all in all, that this angle is equal to that angle, and you add these two together to get that one. Therefore, this angle plus that angle equals 3x minus 25, and then that way you solve x. So where you have two steps over here, you just do them combined in one step over here. Right, then example 9. Determine angle 2 in terms of x. So this angle we're going to determine in terms of x. So we're going to use the exterior angle again. So remember, the exterior angle here will be this whole angle LMN. So we're going to say 22 degrees plus 2x equals x plus 20 plus angle M2. So that's what you see over here. Exterior angle of triangle MKN. Right, then you subtract the x on the left hand side as well as on the right hand side. That's why you see a minus x there. Then you subtract the 20 degrees on the left hand side as well as on the right hand side. And then you get angle 2 equals x plus 2 degrees. Right, now you're going to do exercise 4. It's number 1, 2, 3. Just number 1, 2, and 3. And then we will continue. So you're going to press pause now. You're going to give yourself 15 minutes in which to complete it. So press pause, work it out for 15 minutes, and then you press play. So you get 15 minutes now. Right, you had now 15 minutes in which to complete exercise 4. We're going to mark it, and then we will continue. Right, so number 1, determine the value of x with reasons. Make use of the theorem for the exterior angle of a triangle. Right, so in other words, 5x minus 30 must be equal to x plus 30 plus x plus 30. But first you have to prove why angle BAC equals x plus 30. So therefore you will say angle BAC equals x plus 30 because AC equals BC. Then you will say 5x minus 30 equals x plus 30 plus x plus 30, or in other words 2 times x plus 30, because exterior angle of the triangle ABC. right? Then you will have 5x minus 30 degrees equals 2x plus 60. All the x's on the left hand side of the equal sign, so we subtract 2x on the right hand side, also on the left hand side, then you get 3x. You plus 30 on the right hand side, also on the plus 30 on the left hand side, and then also on the right hand side to get rid of the minus 30 on this side. Therefore you do the inverse, you plus 30 on both sides, and then you get 3x equals 90 degrees. You divide by 3 because you want to get the value of x, not 3x, only x. And then you get x equals 30. And very important, your reasons. Then number 2, BE bisects angle DBF. In other words, and I will have to use no colors in order to do this. In other words, the following: BE bisects angle DBF. So this angle will also be x, because it's like BE is now halving the angle DBF in two exact halves. So x plus x. So determine angle 3 in terms of x, this angle over here, in terms of x. So now we're going to say the exterior angle of triangle ABC will be angle DBC. In other words, it will be x plus x plus x plus 70 will be equal to 90 plus angle 3. And they want you to determine angle 3. So this is how we will go about in doing it. Angle EBF, this angle marked in orange there, x, equals angle DBE, because BE bisects angle DBF. So that just means BE is halving angle DBF into half. So it's x plus x. And then you're going to say angle 3 plus 90 degrees equals 2x plus x plus 70, because it's the exterior angle of triangle ABC. Then you make sure you have angle 3 left on the left hand side of the equal sign, because they want you to determine angle 3. Therefore, the one that you always need to determine needs to be on the left hand side alone eventually. So therefore we subtract the 90 degrees on the left hand side, and we also have to do it on the right hand side, and then you get angle 3 equals 3x minus 20 degrees. Then number 3, determine angle 1 in terms of x with reasons. So they mentioned that BC equals DC. So in other words, this angle will be equal to 20 degrees, like that one, because DC equals BC. So we will use this over here. We will say angle DBC equals 20 degrees because BC equals DC. And then we will say angle DCP, this one over here. And if we just fill in the information that I've written down, that angle over there is now 20 degrees. So now you can see you have triangle BDC, and you have your exterior angle over here. So 20 plus 20 degrees will give me this angle over here, which will be 40. So that's what we're saying now. Right. angle 1 plus 40 degrees equals x plus 15 plus 20. And that will give us angle 1 plus the 40. So let me show you what they're saying here now. There's now actually another way you can do it. So quickly look, we need to determine this angle, right? But before we can do that, we're going to use the information that we have on hand. So angle 1, this angle, plus angle DCP, which is 40 degrees, right? Which is this angle here, because we said 20 plus that 20 must give me this exterior angle, right? So focus now on this triangle here first. DBC, 20 plus 20, because DC equals BC. That's why we know that angle DBC, this one over here, is 20 degrees. So we add these two angles to get the exterior angle, which is 40 degrees. The reason being exterior angle of triangle BDC. Now we're going to use that when we say that angle 1 plus 40, in other words, both of these angles, angle 1 plus 40 equals angle X plus 15 plus 20. Because this angle over here in blue is now the exterior angle of triangle ABC. You see you have another triangle over here, which I'm going to highlight now for you. So this blue angle over here, which is a combination of angle C1 plus 40 degrees, is the exterior angle of triangle ABC. So in other words, X plus 15 plus 20 equals angle C1 plus 40. So that's what we wrote here, exterior angle of triangle ABC. So we want to determine angle 1, therefore angle 1 is alone on the left. So we subtract the 40 on the left hand side as well as on the right hand side. Then we get angle 1 equals x minus 5 degrees. Right, now we do proofs. Example 10. Given DG and EF are straight lines. Right? Now you have to prove that x equals a plus b. Right, so we have our parallel lines. So x equals a plus b. That's what we have to prove. So prove angle F equals angle A. Alternate angles. DE is parallel to FG, so we can clearly see that this angle is equal to that one in size. Alternate angles of a triangle, and then line DE is parallel to FG, and then X will then be the exterior angle of triangle OFB. Sorry, OFG. Right, so let me highlight that triangle quickly. So angle F, and I'm going to write small in it, an X, because that's what we just proved. Angle A here is the same size as angle F here at the bottom, so let's give it this exact same name there. So because angle DEO is the same as angle OFG, we use that small letter A over here, because we just proved it over here, angle F equals angle A. So therefore, angle DOF, this x over here, is equal to the sum of the opposite interior angles, which is A plus B. Exterior angle of triangle OFG, and that's what we just proved. Right, let's do example 11. Given 3, that's what we're going to prove just now. Let's just quickly look what they give us. Angle BAC equals 60, angle ACF equals 80, and then you have AB equals AC. Right, so what we need to prove is that 3 of angle FCD, this angle in other words, times 3 is equal to 2 of angle B. So if I times the size of angle B by 2, I multiply angle B with 2, it will be the same as multiplying angle FCD with 3. So let's see. So prove angle B equals angle ACB, which is 60 degrees, because AB equals AC. And also angles of a triangle equals 180 degrees. Right, so in other words, what you say is these two angles will be the same size because AC is equal to AB. And then we say 180 minus 60 degrees gives you 120, and 120 divided by 2, because we know that these two angles are the exact same size, will give you 60 degrees. So that's how and why we know that angle B and angle ACB equals 60 each. So we write it down. Please take a note of how we've gotten to that conclusion. AB equals AC. Therefore, we know these two angles should be the same size, and we got that by taking 180 minus 60, then you get 120 and you divide it by 2 to get these two angles. Right, so now in order to work out angle FCD, we take 180 minus the 60 minus the 80 because it's on a straight line BD. It's on a straight line BD, so you just take 180 minus 60 minus 80 degrees, and then you get 40 degrees here. And then, as mentioned over here, 3 times angle FCD, which is 3 times 40, gives you 120, must be equal to 2 times angle ABC, which is 60. So 2 times 60 gives you 120, and that's what they asked you to prove. So there you go. All right, then we do example 12. Given AB equals AC, in other words, this angle will be equal to that one in size. You need to prove that angle A is equal to angle ABE. In other words, this angle plus 10 degrees. So prove, therefore, x plus 10, in other words, this angle over here, is equal to this angle over here of x plus 40, because AB equals AC. Then you get all your x's on the left hand side, so you subtract a half x on the right hand side, subtract it on the left hand side, then you get a half x. You minus 10 degrees on the left hand side, also on the right hand side, then you get 30 degrees, and then you times by 2 right through to get rid of the fraction, then you get x equals 60. Alright, so now angle C will then be 60 plus 10 degrees, which gives you 70. So you can write down 70 degrees. So this angle over here, this whole one over here, should also be 70. So 70 plus 70 gives you 140. So in other words, if we subtract that from 180, we will get angle A, which will be 40 degrees. Because the angles of a triangle adds up to 180 degrees. That's what you see over there. And they ask you to prove that angle A is equal to angle ABE. And remember, the value for x equals 60. So a half times 60 gives you 30. 30 plus 10 gives you 40. So ABE equals, as mentioned, 30 degrees plus the 10 gives you 40, and angle A is 40. And that's how you write it out. So angle A equals 180 minus 70 minus 70. These two 70s gives you 40 degrees. The angles of a triangle equals 180, and angle ABE plus 10 is, in other words, a half times 60 plus 10 gives you 40. Half times 60 gives you 30 plus 10 gives you 40, and angle A therefore equals angle ABE plus 10. Right, then example 13, given DB equals AB, determine the value of x, and then they tell you that angle ABD equals x and angle ACB equals x, and also you have this angle CBD which equals 24, and you need to determine the value of x. So you will start off by saying angle ADB, DB, in other words this one over here, equals x plus 24. Because it's the exterior angle of triangle CDB. So you add these two angles to get to the exterior angle there. So this angle ADB equals x plus 24 degrees with the reason. Then we say that then if this angle ADB equals x plus 24, then angle DAB will also be equal to x plus 24 because AB equals BD. Therefore, angle DIB equals x plus 24. So both these angles are equal to x plus 24 degrees. And then we just add the interior angles of a triangle. So x plus 24 plus x plus 24 plus x equals 180, because the sum of the angles of a triangle ADB equals 180 degrees. So you get to 3x equals 180 minus 24 degrees. Then you get to 132, you divide by 3 because you only want to solve x, and then you get x equals 44 degrees. And you can always test it by substituting the x with 44. And then when you add them together, you will get to 180 again. Right, then we have the homework, and you're going to get 15 minutes in which to complete the homework, which is number 1 to 4. So just do number 1, 2, 3, and 4 for me of the homework, and do it within 15 minutes. So you have 15 minutes now in which to complete it. Right, you received now 15 minutes in which to complete the homework, number 1 to 4. Right, so for the first one, determine the size of the largest angle in triangle PRQ, in other words, in this triangle over here. Right, let's quickly look. They give you that MR equals MT and PQ equals PR, and then they give you one angle here, angle MTR, which equals 11 degrees. So we will do the following. You will say that angle R over here, MRT, or in other words, R1, angle R1 equals 11 degrees because MR equals MT. Then we'll say angle M1 equals 22 degrees because it's the exterior angle of triangle MRT, where you have to add R1, angle R1 plus angle T. So it's 11 degrees plus 11 degrees gives you 22 degrees. Exterior angle of triangle MRT. Then you do angle P1, which is that one over there, which will be also 22 degrees because PR equals RM. Then angle R2, this one over here, adds up to 136 degrees because the angles of a triangle adds up to 180. You have 22 degrees plus 22 degrees, so you add the two together and you get 44 degrees. You subtract that from 180 and you get 136 degrees. Then angle R3, this one over here, equals 33 degrees because it forms a straight line which is equal to 180 degrees. So you have to have the 136 plus 11 gives you 147 degrees. So you subtract that from 180 because that's what the straight line angle measures, a stretched angle. You subtract that and you get 33 degrees. And then we say angle R3 is equal to angle Q1, which is equal to 33 degrees because PQ equals PR. And they ask you determine the size of the largest angle of triangle PQR. So then you say angle P2 equals 114 degrees because the angles of a triangle equals 180. So 66 degrees, and you subtract that from 180 and then you get 114 degrees. So the size of the largest angle will determine the size of the largest angle. It will therefore be 114 degrees, which will be angle P2. And just take a look at all the different reasons you had to give. So this question tested basically all your knowledge of today's lesson. Then number 2, determine the value of x with reasons. Right, so that angle over there, you start off by saying 2x plus 39 degrees, this angle, plus 21 degrees equals 90 plus x. Now, why is that? You have triangle LKM. Let me just do it properly. You have that triangle there. I'm going to quickly indicate the exterior angle in purple. It's this one over here. Right? So if I add 21 degrees plus 2x plus 39 degrees, I get angle KMO. Angle KMO consists of the 90-degree angle plus x. So therefore we write 2x plus 39 degrees plus 21. The sum of the two interior angles equals 90 degree plus x. It's exterior angle of triangle KLM. And then because you have to determine the value of x will be on the left-hand side. So we're going to subtract 39 degrees and 21 degrees on the left-hand side as well as on the right-hand side. And then we just divide by 2 because we want x only. Then we get x equals 30 degrees. And then question 3. DOE is a straight line through center O of the circle. O and P are joined. So in other words, we have a radius there. A radius there and a radius here. Right. Let's just try to use the color quickly. Right. For some other reason, we have a technical problem now here. You need to make a note on your paper that PO equals OE equals DO because they are all three of them are radii. So this is a radius, PO, OE is a radius, and DO is a radius. Right, so they are the same size. So therefore angle P1, sorry, let's just quickly get to the question before we do that. Determine the size of angle P2, that angle over there. See, there we go. Now it's working. So just indicate on your sketch PO equals OE equals DO. Okay, we need to determine size of angle P2. So angle P1, this angle over there, will be equal to 44 degrees because PO equals OE. And you see the reason, radii. Then angle O2, this angle over here, will be the exterior angle of triangle POE. So it's 44 degrees plus 44 degrees gives you 88 degrees. So angle O2 equals 88 degrees, exterior angle of triangle POE. Right, and then in order to determine this one, let's just quickly write down 88 degrees here. So in other words, angle P2 will be equal to angle PDO, right? Because PO equals DO. So therefore, we say 180 minus 88 degrees divided by 2 gives you 46 degrees. So each of them will be 46, 46. Right, which gives you then 92. So 180 minus 88. And then you divide that by 2. Then you get 46 plus 46. So 92 plus 92 plus 88 gives you then the 180. Right, let's quickly look at question B. Right, determine the size of angle DPE. So DPE. So now you take 46 plus 44 degrees. So angle P2 plus angle P1, because they form together, angle P1 plus angle P2 form angle DPE. So 46 degrees plus 44 degrees gives you angle DPE, which equals 90 degrees. So that's a 90-degree angle. Right, and then question 4. All right, given angle B equals a half times angle C. So you have to write down for angle B, it's a half times the size of angle C. So prove, in other words, that angle B equals a half times angle A. So firstly, we're going to write down information given. Angle B equals a quarter x because a half times a half x gives you a quarter x. That's your reason. That's what they mentioned here. So a half times angle C, and angle C equals a half x. So a half times a half x gives you a quarter x. So this is a quarter x. Let's write it down. A quarter x plus a half x plus 200 degrees minus x equals 180 because the sum of the angles of a triangle equals 180. Then you get minus x plus 3/4 x equals minus 20 degrees. That gives you 3/4 minus 3/4 x minus x gives you minus 1/4 x equals minus 20 degrees. And then x equals 80 degrees. Therefore, angle B equals 20 degrees. So 1/4 times 80 gives you 20 degrees. And therefore, angle A equals 200 degrees minus the 80, because x equals 80 gives you 120. So angle B equals 20. Let's just write it down. 20, and angle A equals 120. So let's see where it works out. 20 which is 20 degrees equals a half times angle A. Angle A is 120 degrees. So that's then basically it. 120 divided by 6 gives you 20 degrees. So that's true. You just prove that angle B equals 1/6 of angle A, or a 6th times angle A. Right, I'm just quickly going to just read through the extra exercise because yeah, we ran out of time and it wasn't for homework, not for homework. Just to show you the important parts which you need to focus on when you study for the exam. So they give you that line RA is perpendicular to PQ and BQ is perpendicular to PR. And then they ask you prove that angle BOR will be equal to angle P. And then they also give you a hint that angle BOR, in other words, this angle over here, equal to X. Okay, struggling again there. Okay, we will do it just now. Equal X, and angle BRA, that angle there equals Y. So that this angle is Y, this angle is X. So in question 1 there, then you will say angle P plus angle BRA. So this angle plus angle BRA equals 90, because the sum of triangle PAR equals 180 degrees. Right, I just want to highlight this quickly. So angle P, that angle there, plus angle BRA, plus this angle here. That angle plus this angle equals 90 degrees. Sum of the triangle PAR equals 180. Therefore, angle P plus angle Y equals 90 degrees. But angle BOR plus BRO equals 90 degrees because it's the sum of the angles of triangle BOR, which will be equal to 180. Thus, therefore, angle BOR plus Y equals 90. So BOR plus angle Y equals 90. Therefore, angle P is equal to angle BOR, which equals X. And then question 2, prove that angle BRA, this angle in other words, is equal to angle PQB. Right, so angle P plus angle PQB equals X plus angle PQB equals 90 degrees. So if I add angle P plus angle PQB, it's equal to X plus angle PQB, which equals 9. So it's equal to 90 degrees. So it's the sum of angles of a triangle. PQB equals 180. Therefore, angle PQB equals Y. Thus, angle BAR is equal to angle PQB. Now, unfortunately, as mentioned, we have to go through this quickly now because we just passed our time for the lesson. But if you have any questions regarding any of the sums that we've done in today's lesson, you can always email if you have any other questions, and we will have some live sessions in 2016. Right, so we can quickly look at question 2. Given PC bisects angle TCB. Right, so PC bisects angle TCB. In other words, this angle will be equal to that angle over there. And PB bisects angle TBA. So these two will be the same then. So you need to prove that angle P is equal to a half times angle T. Alright, so they give you a hint once again. Let angle TCP, that little red angle there, be equal to X, and angle PBA, this angle over here, be equal to Y. Right, so how do we go about improving it? So we say angle PBT equals angle ABP. So let's do it slowly. PBT, that angle there, is equal to angle ABP. And the reason for this being this part over here, PB bisects angle TBA. So they're the same size. It's almost like halving angle TBA. Right, given. Then you say that angle PCB equals angle TCP, which will be equal to X and X. And the reason there being PC bisects angle TCB. It's also given. Therefore, angle P is equal to Y minus X, the exterior angle of triangle PBC. So when we look at angle triangle PBC, we can say that angle P is equal to Y minus X, because that's the exterior angle of triangle PBC. So we subtract it. And then angle T, that angle there at the top, is equal to 2Y minus 2X. 2Y minus 2X. Exterior angle of triangle TBC. Therefore, just look how clever this one is. Angle P is equal to a half of an angle T. So Y minus X is a half of 2 in brackets Y minus X. So it's clear to see that Y minus X is half of 2Y minus 2X. Isn't that smart? And then guys, the last question. If you struggle with this advanced activity, don't be worried. There's a reason for it not being part of the homework. It's because it's just to give you that extra challenge. So you will notice that we didn't have any of them last week. So if you struggle with this is normal. This is like a higher grade, higher ADMAPS grade question, just to test your thinking skills. So don't be worried if you struggle with this. This is supposed to be challenging. So question 3, KP is equal to KA, right? Therefore, angle these two will be the same in size, and DP equals DA, so these two will be the same. So you work with a big triangle PKA and the smaller triangle PDA. So now they tell you that angle D is 108 degrees and angle KPD equals 12 degrees. And they want you to determine the size of angle K, this one here at the top. Right, so firstly you're going to start off with saying that angle DPA, in other words this angle over here, that one there, is equal to angle DAP. Alright, let's just try to highlight it quickly. Also doesn't want to work. Right, that angle there, DPA, equals angle DAP. DAP. Right, because DA equals DP. And then in order to get angle DPA, you're going to say this angle alone over here, 180 minus 108 divided by 2. So we take, in other words, in order to work out what's angle DPA, the small one over here that's marked there in green, to get that size of that angle, for example, because we know that angle DPA is equal to angle DAP because of line DP being equal to DA, we're going to subtract 108 degrees from 180, and that answer we're going to divide by 2 because these two angles are exactly the same size. Then you get 36 degrees. With your reason, the sums of angles of an isosceles triangle are equal, so DP equals DA, so that's your main reason, DP equals DA. And then you say that angle KPA in the big triangle, the one that you see here in red, is equal to angle KAP, which is equal to 48 degrees, because you just determined this one now. 36 plus 12 degrees gives you 48 degrees. So the angle over here, KPA, equals 48 degrees. Therefore, angle KAP will also be equal to 48 degrees. Now it's easy to say 48 plus 48, right? Together gives you 96. So 100 degrees, 180 minus 96 degrees gives you 84 degrees, because the sum of a triangle gives you 180 degrees. So therefore, angle K there at the top will be equal to 84 degrees. So I'm just going to explain it again. You started off with working with a smaller triangle, and we determined the size of angle DPA by saying 180 minus 108 degrees, and we divided that by 2 and we got 36 degrees. So angle DPA equals 36 degrees and angle DAP equals 36 degrees because DP equals DA, and when we add 108 plus 36 degrees plus 36 degrees, we get 180 degrees. The sum of a triangle, the sum of the angles of a triangle adds up to 180 degrees. Then we use the 36 degrees and we add it to 12 degrees. Then we got 48 degrees. So we know that angle KPA equals angle KAP because of KP being equal to KA. Right? So now we have 48 plus 48, which gives you 96. So 96 you take away from 180 and you get 84 degrees. In other words, angle PKA, in other words, angle K equals 84 degrees because the sum of the angles of a triangle adds up to 180 degrees. Right, so that will be it. Thank you for working so hard, and go through today's lesson again and make sure that you understand.